Okay, here's number 12, which I actually forgot to do on the review paper. Sorry about that. And I will also do number 13. So in number 12, we need to state the possible rational zeros and then find all zeros. So if I do my factors of 5, I have 1 and 5, and my denominator is going to end up being the same. And I have to do 1 over 1 and 1 over 5, which is going to give me positive negative 1 and also positive negative 1/5. And then 5 over 1 and 5 over 5. Well, 5 over 5 is also 1, so I don't need to do that one again, but 5 over 1 will give me positive and negative 5. Well, this is a shorter list than the last one, number 11, so if you had to work through a lot of numbers for number 11, this one will be a lot easier. All right, so let's try the 1. And let's see, I'm not missing any terms. So 5, 31, 31, and 5. So bring down 5. 1 times 5 is 5. Add that, I get 36. 1 times 36 is 36. Add, I get 67. 1 times 67 is 67. And add, I get 72. Well, that 1 is, again, these are all positive, so we have an upper bound, so I don't need to try the 5. So let's go ahead and try negative 1 before I have to try any fractions. And we have 5, 31, 31, and 5. I bring that 5 down. Negative 1 times 5 is negative 5. When I add, I get 26. Negative 1 times 26 is negative 26. Add straight down, I get 5. Negative 1 times 5 is negative 5, and I get 0. All right, perfect. So again, we started with x cubed. This will be x squared. So I get 5x squared. I'll write that down here. 5x squared plus 26x plus 5. It's a quadratic, so I could use quad 3 on the calculator or the quadratic formula. And when I do that, I will get negative 5 and negative 1/5. Okay, so my zeros, with that negative 1 up there, negative 1, negative 5, and negative 1/5. Okay, all right, let's look at number 13. Number 13 says, state the possible number of positive and negative zeros for each function. This is where we take the f of x, the original function, and we look at our sign value. So the first term is positive. The second one is positive because it's got a plus out in front. The third one is also positive. The fourth one is positive. This next one is negative because it's minus 8x and minus 40, so negative. What we're looking for is how many times do we change signs? Well, we only change signs from 75x squared to minus 8x. So that is one sign change, which means we have one positive real zero. And so for the negative, we have to do f of negative x, which means we're plugging in negative x for all of this. So 2 times negative x to the 5th plus 10 times negative x to the 4th. Let me start that over. Okay, so 2 times negative x to the 5th plus 10 times negative x to the 4th plus 15 times negative x to the 3rd plus 75 times negative x squared minus 8 times negative x minus 40. Negative x, whenever you have an odd number for an exponent, the negative x is going to stay as a negative. And then you combine that with the value out in front of the term. So you have a negative and a positive, which is a negative. Here, on the second term, our exponent is 4. So that's going to make that negative x become positive x. And because we have plus 10 out here, it's going to be a positive term. With the negative x here, with an odd exponent, that stays negative. A positive out in front, combined with a negative here, is negative. The negative x squared is going to convert to positive. We have a positive out in the front to keep it positive. Here we have negative x times the negative 8, which is positive. And then the negative 40, you never, ever, ever change the constant term because you can't change it by plugging in a negative x. There's no x there. So we have one sign change there, one sign change there, one sign change there, and one sign change there. And I missed that on the review. So I have 1, 2, 3, 4 sign changes. So that means I have 4, and then I drop by 2's. So 2 or 0 negatives. Okay? Sorry about that for having that mistake on the review. So 1 positive, 4, 2, or 0 negatives.